Your phone feels slow, so you swipe the app switcher empty, card by card. Every card in there looks like a program still running. Not one of them was. A frozen app gets no processor time and executes no Codia, and iOS is so set against building one from scratch that it will sometimes start an app you never opened, load it, and freeze that too, just in case. That list was never costing you anything. It was work your phone had already finished. Frozen is not a figure of speech. On iOS, when you leave an app, it moves to the background briefly, and then the system suspends it. On Android, it becomes what the documentation calls a cached process, and since Android 13, it may get limited execution time, or none at all. Different vocabulary, one behavior. The app stops, though it has not gone anywhere. Its code is still unpacked in memory, the screen it drew is still built, the file it pulled off storage is still sitting where it landed, and nothing whatsoever is stepping through any of it. So a frozen app spends exactly one thing, and that is room. Room also happens to be the one resource a phone genuinely runs out of, which makes the next question obvious. If it does nothing and it takes space, why keep it at all? Because that space is not storage, it is a cache. Google's own memory documentation puts it plainly. When someone first launches an app, a process is created for it. But when the person leaves, that process does not quit. The system keeps the process cached. If the person later returns, the system uses that same process again, which is what makes switching between apps faster. Take that as an accounting statement rather than a technical one. The megabytes an app is holding are not litter the system failed to sweep up, they are receipts. They are the code already unpacked, the layout already measured, the pictures already decoded, the answers already fetched. Every expensive thing that had to happen once before you saw anything on that screen. Free memory is the only kind with nothing in it, which is why a phone with hardly any of it is usually a phone doing its job. That only holds, of course, while nothing else needs the room. When something else does need the room, the system takes it and it does not ask. Apple states the priority flatly. The foreground has priority over memory and other system resources, and the system terminates background apps as needed to make those resources available. Android publishes the order it works through. Foreground first, meaning whatever is on your screen right now, then visible. Then anything holding a running service like music that is actually playing. Then cached, which is everything you are not currently looking at, and which is first out the door every single time. This is the same machinery that hands every program its own private memory running in the other direction. So when you flick a card away, you are not making a decision the system had been waiting on. You are casting a vote in an election that was already decided. Coming back to a frozen app and starting one over are not the same operation, and Android names 3 cases. A hot start is when the process is still there and the interface is still in memory, so the system brings the app forward and skips creating the objects, building the interface, and drawing it. A cold start is the opposite, and the documentation's own phrase for it is starting from scratch. The system creates the process, puts a blank window on your screen while that happens, and then the app has to create itself, start its main thread, build its first screen, and draw it. You already know what a cold start feels like at a much larger scale, because it is what your computer is doing while you watch a logo in a spinner. Google publishes the bar each of the 3 has to clear. A start gets flagged as too slow at 5 seconds if it is cold, 2 seconds if it is warm, and 1.5 if it is hot. Those are limits rather than averages, and what they encode is a judgment, because the people who set all 3 think a start from scratch may take 3 times as long before anyone calls it broken. That judgment is written down somewhere sharper than a performance target. Sitting in Android's notes for developers is a rule about other people's apps worth hearing whole. Your app should not use the kill background processes call or otherwise attempt to influence the process lifecycle of other apps. Android is designed to keep cached apps in the background and to kill them automatically when the system needs memory. If your app kills other apps unnecessarily, it can reduce system performance and increase battery consumption by requiring full restarts of those apps later, which takes significantly more resources than picking up an existing cached app. Sit with what that describes. This is not advice about being tidy. It was considered harmful enough that in Android 14 the call was disarmed. Point it at somebody else's app now and nothing happens. And a line turns up in the log rejecting the package name. One app is forbidden from doing this to another in writing for reasons given in the same sentence. The gesture in your hand is covered by no rule whatsoever. The strongest objection to all of this is a fair one. On a phone short of memory, the app you flicked away might well have been the very next thing the system took anyway. So what did the swipe actually cost? That is true, and I think it is true more often than not. Look at what it concedes though. The best outcome of the gesture is that it matched a decision the system was about to make on its own for free, at a better moment using information you cannot see. It can tie. It cannot win. Every time the system would have kept that app, which on a phone with room to spare is most of the time, the swipe throws the work away and bills you for it again. Apple's support page names the one place the gesture earns its keep. You should close an app only if it is unresponsive. A stuck app, or one genuinely working in the background because it asked permission to, is what the gesture was built for. Bring that switcher up and look at what is actually in front of you. Every card in it is a process the system chose to keep, holding the finished result of work it has already done once and would rather not do twice, sitting in memory that costs almost nothing and would be handed back the instant anything else needed it more. Your phone is not laboring under the weight of them. It is holding them the way you leave a book face down on the arm of a chair instead of closing it and finding your page again tomorrow. The gesture you've been using to help is the one move in the entire arrangement that closes the book. Your phone was never waiting to be told which apps to keep. It has the ranking, it has the numbers, and it takes what it needs without mentioning it to you. Nothing in that list was running. All of it was ready.
Everything you just figured out rests on something deeper, and that's the next video, so start there. Would you rather understand your computer than just use it? Then subscribe, and I'll see you next time, further down the stack.